It's just 1. Yeah.
Yep.
Second one is -2 times 3, so that's -6 plus 6 because there's a minus sign.
Mm-hmm.
And then the last one is -9.
How do you get -9?
Oh
Zero,
wait,
0 times
-8. Yeah.
minus
Min-
8, I believe.
So that's -1.
So the determinant of A is -1.
Mm-hmm.
Let me bring this thing back now. From the matrix, form the matrix of the minors of A. Yes, but is that what I'm thinking? Yep. Hang on.
But then wouldn't there be like 4? Yeah.
Yeah,
Okay.
that's what I thought. So 4, 1, -1, 0. Yes. So the so we then have the whole matrix. Let's hope I have enough room. Okay.
This is a really long process.
Yeah. So we'll just do it once.
So the first one is like 4, 1, -1, 0.
Yeah. Oops. -1, 0.
And then 0 to 1, 0. Yeah.
If you're going that way, is it?
I don't, yeah, I think that's right.
That 0, 1, 2, 0.
And then 0, 4, 2, -1. 3, 1, -1, 0.
What are we doing now? This one. 3, 1, -1, 0. Yeah.
And then 0, 1, 2, 0 again.
So I believe we're on this middle one.
Oh, okay. 1, 1, 2, 0. 1, 3, 2, -1.
Yeah.
3, 1, 4, 1.
3, 1, 4, 1. Yeah.
1, 1, 0, 1. 1, 3, 0, 4.
That is it. We now do AD minus BC for each one of those.
Oh, wow. Okay. So the first one is just 1. -2. -8. 1 again. -2. 7.
Is it -7?
No, because we have 6 -1.
Isn't it -1, -6? AD minus BC.
Oh, okay.
So I believe that's -7.
Yeah, it's -7. -1. 1. 4.
And we multiply that by 1 over the determinant.
So that would just be -1.
Yeah, but actually before that we have to rearrange the signs.
Oh, to change.
We have to change the signs, so same change, same change.
And then, yeah.
So what changes?
So it's plus. So, wait. So the first one has to be plus, but it already is.
So that means it stays the same.
Okay. So the only one that needs to be changed is like the -8 needs to become +8.
Uh, uh, this is short for same, change, same,
Uh,
change. So
okay.
you multiply it by +1 or -1.
Okay. I got it.
Alternating signs, hopefully. Yep.
So 2, and then -1. Yeah. And then 7, and then -1 in the middle one. Yeah.
That is it.
It says you have to like change the transpose. Isn't that when you change the rows and the columns? Like you swap the rows and the columns.
Let's see. So find the determinant of A. Form the matrix of the minors. In this chapter, symbol M is used for the thing. In forming the matrix of minors, each line is replaced by its minor. From the matrix of minors, form the matrix of cofactors by changing the signs. Okay. You leave the elements corresponding to unchanged. You change the signs. Write down the transpose of the matrix of cofactors. Yes. So what is the transpose of?
That's like when you swap the rows and columns, right?
Yeah. So I'm just
So
gonna.
it'd be 1, 2, -8 going down, I think.
I'm just gonna just do that. So, excuse me. Yes. So 1, 2, -8.
-1, -2, 7,
So,
like going down. Yeah.
so it's -2, 7,
-1, 4.
and -1, 4.
And then now you have to times the whole thing by -1.
And the inverse given by this formula, 1 over the determinant times transpose. Yep. And so times everything by 1 over -1, which is just -1. And so what does that become?
-1, 1, 1. -2, 2, 1. 8, -7, -4.
Okay, so let's hope we didn't make any little mistakes in there,
So,
but that's what we believe our answer is. -1, 1, 1, -2, 2, 1, 8, -7, -4. 1.
oh, that's only step 2.
Oh.
That's not the answer. Okay.
-1, 1, 1, -2, 2, 1, 8, -7, -4. Okay, let's go back to the very original thing. Here's the bit that you hate me for. Just put it in the calculator. Matrix 4. So I'm going to use simple one. Define matrix 3 by 3. 1, 3, 1, 0, 4, 1, 2, -1, 0. Matrix calc. Oops. Option. So what did we just find for this whole thing? The determinant.
No, wasn't it the... Yeah, we know. I think it was something else. It's like the inverse or something.
Ah, yeah. But we don't have that. Is that right? So to get the inverse, or do you have the inverse on your one?
I can't see one that says inverse.
Okay, so we can do 1 over the determinant. So I'm going to do 1 fraction and then option, press down, determinant of option matrix A. And then do that. I'm going to put a bracket around the whole thing just in case, because I'm scared. times by the transpose of A. So option, the transposition, option, matrix A.
I think this is transpose. Oh.
Are you on graphical one?
I got a math error and I did that.
So this is what I have. -1. Ooh, I put something in wrong. 0 minus. I got something wrong. What did I get wrong? Press up. Press.
It should be 131. 041.
Are you using graphical?
Yeah.
Okay, I should use graphical. Did you get the right answer?
No, it said math error. I put this in my calculator. And wait, I don't know if you can see it, but
1 over determinant A. 1 over, it's get rid of matrix A. So it's just 1 over the determinant times the transpose.
okay. It's still saying math error. I don't know why.
So this is it down here.
Nope, it doesn't like.
Maybe it's the cofactor. Okay, is there some way to just like get the inverse?
I don't know.
I'll just
There isn't a button that says inverse, which is really weird. I have like the same buttons, but
so our one is which is matrix? Which one is matrix on graphical?
oh, you press up. Yeah, just do run matrix, I think. I'm just using that one.
Makes sense.
I don't know if there's a specific.
No, it's run matrix.
Yeah, and then that button that says MAT is matrix.
So matrix.
That's how you can like add them.
Okay. Let's go back. 1, 3, 1, 0, 4, 1, 2, -1, 0.
And then just exit.
Option calc. Oh.
No, you have to press like exit and then yeah. Oh. Maybe press the equals button at the bottom. Oh wait, no, just press exit again. Don't press like menu or anything. Yeah, and press it again. And it should, yeah. And then press option. And then the second one, it says MAT. Yeah, and then you get all the matrix stuff.
Determinant, that's probably transpose. Identity, fill, vector, dot product, unit vector, angle, cross product, normal. Ooh, okay, I'm gonna have to find this. Otherwise we have to do this the inverse of matrix A is given by this formula. Each A is divided by the determinant of A. So we did. So that's just okay. So the determinant of A. So we can find the determinant. Then from the matrix of the minors. No change. Look at elements. You write down the transpose CT of the matrix of cofactors. All right. We'll just see how this goes.
We have to do this every time. It's so
I suspect not. So there is a kind of a quicker way if you notice something. So this one here, you know the way we did A, B, and C? That's A, that's B, that's C.
Yeah.
If you go down and you say that's A, that's B, and that's C, then the middle one is times 0. And so you can just get rid of that one altogether. And little things like that speed it up. But I think, well, we'll see. Okay, this one. K is not 0. Find the inverse of this one. Well, that's just to make us do the whole thing again, is it?
Yeah.
All right. We'll be quick.
I know. This is a lot of steps.
Okay, let's try this one. Okay, determinant.
Okay, 3. And then
Yeah.
K 0 minus 3, 3. And then minus 2.
Mm-hmm.
And then minus 2, minus 1, 0, 3. Is that like the right? Yeah, okay. Plus 2. Minus 2, K, minus 1, minus 3. Okay, and then determinant of them. So 3 times K minus 3. Wait, no, 3K. Yeah. And then plus 12. So 2 times 6 plus K. So 9K plus 12 plus 12 plus 2K. 11K plus 24. So that's determinant. Okay, now we get to do the minors thing. So the first one is just K0 minus 3, 3.
I just need more space. Maybe I'll just...
Yeah, you can just make that smaller.
Okay, so 1. So hopefully something like that.
K0 minus 3, 3. Then minus 2, minus 1, 0, 3. Wait, minus 2, 0, minus 1, 3. Yeah.
Mm-hmm.
Minus 2K minus 1 minus 3.
Minus 3, yep.
Two minus 2 minus 3, 3. Yeah.
Yeah. Yeah, I think we get the idea, am I right?
Yeah.
All right, and we'll just
But you
move.
can't find it unless you do everything.
Yeah, this is so long. I think we're okay though. Let's take a
Yeah.
look. So yeah, we'd keep doing all those. This is what you end up getting.
Then you change the sign.
I'm gonna change the signs.
Then you swap it, and then you, do that.
Okay, grand. The matrix A is this, matrix B is that. A, the inverse of that, show that A inverse is equal to A, find the inverse of B. So show that the inverse of A is A. How would we do that?
Find the inverse of A.
Yeah, and that would just take a long time.
Prove.
And then how would we find the inverse of B?
Well, since you know what the inverse of A is, you could just divide the AB inverse one by A inverse, and that would give you B inverse. Is that right?
I think so. Let's see. The inverse of A times B, I think that is the inverse of A times the inverse of B.
Mm-hmm.
And so the inverse of A So they give us this. So the inverse of A times the inverse of B is equal to this big matrix here. And we want the inverse of B. So I believe what you could do is the inverse of B is that matrix times by A.
Oh, yeah, okay.
It's like you times both sides by A. And we said, let's try a new calculator.
Mm, mm. I got B inverse is equal to minus 2249 minus 24.
Okay, just one second. I just wanted to experiment with something.
The middle row is weirdly the same.
I wanted to check something, and I think I was right that A times B isn't the same as B times A. Yeah.
Why? Yeah, that's why I got minus 2249.
So I just want to. So I said we multiply both sides by A, or we do A to both sides essentially. But I'm just wondering. Let's see. So the answer was minus 7, minus 2, minus 6. So the answer was this one. So what we have here is like that times A. Did you do like B times A? Or C times A, if you like?
I did A times B.
So, which one?
I put the.
I did B times A. Yes. So you have to do.
Oh, you have to do B.
I'll call it.
A.
I'll call it little b because we shouldn't use the letters like that. But yeah.
Oh yeah, when I do B times A, I got the right answer.
Yes. So there's a difference. So I did A to both sides, and so I got that. So this is the correct way to do it. You can't swap them. Yeah. And let me just see this one. So proving it, A squared is this. AA is I. Right. Also, okay. You'd probably just find the inverse. So that's where. So AB, the inverse of A times B is the same as the inverse of B times the inverse of A. So they're not actually the
Why is that the same?
Yeah, those two aren't the same.
Okay.
So there you go.
Why is it like that though?
Sorry?
Why is it like that?
It is.
Because surely it doesn't matter what order you do it in.
Yep, sure does. Calculator disagrees. It's like a rectangle. Length. The length and width isn't the same as the width and the length.
Okay.
Essentially. So if we were to multiply these by each other, it's like each row by each column, and you would you'd get different numbers, different order. Let's just see this. So B times both sides by A, and those two cancel out, and so you get B inverse. Yep. Okay, grand. Any questions there?
No, it's just really long.
Yeah. Okay, so show that the determinant is that, and then find the inverse. Do you want to do it, or you think you'd be okay?
I think it's okay. I mean, it's not that hard to find the inverse. It's just really long.
Yeah, I think there's more interesting questions as well. Given that A is equal to the inverse of A, so this might be good.
Doesn't that mean that it's identity matrix or something?
That
But it said it
means,
before.
what if you were to multiply both sides by A? What would you get?
A squared is equal to 1.
A squared is equal to the identity matrix I. Do
Okay.
you know what the 3 by 3 identity matrix is?
No?
It's a diagonal, I think, of zeros.
Okay.
There it is. Sorry, diagonal of ones.
Okay.
And so that means A squared is equal to 1.
So would you have to like square A to prove this? Or would you just find the inverse?
Um,
I feel like squaring A is probably the same length as like finding the inverse.
it'd probably be easier to square A, but
Um,
that you only need like that's A there. So just do the things that affect, that's B there.
no, there's the C as well at the bottom. So,
Yes. My point is you don't have to do
oh, you
like
don't have to do all the.
everything else. So go on, try it. Let's try to find A. 5A, 2 minus 2C.
Oh, do you have to do the complicated like adding and multiplying thing, right?
Yeah. So it'd be like 5.
Yeah, times 5 and then A times B, right?
5 times 5 plus
AB
AB
minus 8.
minus 8. Hang on, so what were you multiplying it again?
I did the 4 times the minus 2. Oh,
Uh,
wait, it should be a 2. Okay. So it should be plus 8 then.
Yeah. So plus 8. And that's the top left one. So that's equal to
1.
1. So that's got A and B.
Then should I just do like the next row?
So yeah, try one more.
5A minus 7A minus 8 is equal to 0.
So you could get A from that.
Yeah, 12A is equal to 8.
No,
So A is equal.
No. That's
Oh, minus 2A is equal to 8. A is equal to minus 4. Yeah.
And so what is B?
B is equal. Is equal to minus 33. Minus 4B is equal to minus 33.
33 over 4?
Yeah, which is 8.25.
Okay. And I was just trusting your numbers in there. A is minus 4.
Oh, B is 8.
Hang on.
Apparently.
A is minus 4. Let's see. So B, did we not do this first one right? So 5 times 5 plus A times B plus 8 equals 1. They're saying that's AB plus 33 equals 1. We are getting 25. Yeah, we have the same thing. Am I crazy? Did you get this 33 wrong? Should that be 24?
No, 25 plus 8 is 33.
25 plus 8 is 33. So that should be minus 32. It's equal to 1.
Oh, there's a 1. Okay, that makes a lot more sense. So that's just 8 then. No, it's minus 8.
Minus divided by minus.
Oh, 8. Never mind.
So B is 8, and then you'd do something similar to get
C.
C.
Okay.
Any questions there?
No.
So we only had to multiply. Yeah, you'd probably end up only having to multiply 3 different things if you had 3 unknowns. Ooh, what is this?
I don't know how to find that.
Inverse of A.
Does M have an inverse? Complicated.
That's all the information you need. When won't there be an inverse?
When the determinant is equal to 0?
Yeah.
Okay. So you need to figure out.
So they said not, so I'll leave it as equals 0.
Okay.
No, they didn't say not. They said it does.
So the determinant formula. Okay.
Oh, hang on. Would we have to do the whole thing?
I don't know.
Is there some quick way?
You could use the calculate. No, you can't. Never mind.
For which values of k does M have an inverse? So if we did the inverse for this whole thing, the whole cofactors, find M inverse in terms of k. So then they just ask you to find the inverse anyway. All values of k.
Okay.
Does M have an inverse? Okay. So the matrix of the minors. So this is the inverse. The determinant is this. Ah, they got lucky. Because it turns out it's minus k times by 0.
Oh, okay.
And so because k isn't in the...
it can be anything then.
Yeah, it isn't in the inverse, then it doesn't matter. Okay, but we got a little reminder. Any questions there?
No.
Okay.
Bit bad.
Find A inverse in terms of P. Just more finding the inverse.
Mm-hmm.
Alright. Find the determinant, just the whole thing. Okay.
Would you actually get asked to do this in a further maths exam? Like, so long.
Yep.
Yeah, I understand how to do it, but super long.
And so now we...
Bad for my friends who do further maths.
Now you see why we were doing this inverse malarkey. You can use the inverse of a 3x3 matrix to solve simultaneous equations when there's 3 things.
Okay.
So if you have A xyz is equal to V, then xyz is equal to A inverse times V. And then V is a vector. Okay, using the inverse matrix to solve these simultaneous equations. Any idea how you do this?
I don't understand. What's the A meant to be?
I believe, in this case, A is -1, 6.
Oh, like that.
2.
Okay. I get it. So 6 minus 2 minus 1 minus 2, 3, 5. And then
Um,
it's just X, Y, Z. Okay.
and that's equal to?
A inverse.
That's equal to
Wait,
21
equal to V. Okay.
minus 60 and
Okay.
24.
Okay. And then
So,
you just times is equal to A inverse V.
yes. Hold on. Do the Googles. Casio calculator inverse matrix. Let me see if I can do it on the old calculator easily. Let's close this one. Matrix is 6. Matrix A, 3 by 3. Yeah. Oh, this was never easy. There's no matrix stuff
I
though.
have to go back, but I don't know how you do that.
Oh no.
Maybe just press equals again. I don't know. I've never seen one of those.
It's an oldie but a goldie. Store. So stats complex. Ah, there it is. So shift and then 4 for matrix. Dimension or data. So it just tells me the dimensions. Oh, I need to press AC to save it. Shift 4. Determinant. The transposition. Huh. Dimension.
What about matrix answer? What does that do?
I think it's just the previous matrix answer.
Okay.
There's gonna be some easy way. There's gonna be. If you're able to do it with that. Not you, video. Enter matrix. X and minus 1. Shift.
I would have an X to the minus 1 button.
Hang on. Shift 4.
Calculator.
And they're saying 3. That's just matrix A.
Yeah, it gives you the inverse of matrix A, I think. But I don't have an X to the minus 1 button.
Which one is he using there? 991. Yes. Inverse of a matrix. Wait.
615.
Hold. Wait.
Shift.
Transpose.
Mode.
This is just crazy enough to work.
Oh, I found the X to the minus 1 button on my calculator.
Where is it?
It's like the bracket. It's one of the, like, it's above the bracket one. Like, if you press shift bracket.
Okay. Is it?
It is on mine. It's a comma, that one.
Is it literally just to the power of minus 1? Is that really?
I don't know.
Okay, matrix A is that. And so.
Oh, it actually worked. I mean, it gave me an answer. I don't know if it's right, but.
Oh, that's a game changer. Didn't know this.
This is so good.
So let's do it with this one then.
Yay! So, inverse of that.
Yeah.
This is a minus 1, 6. This is amazing.
You're amazing. There we go. Option. Better define matrix B. Option 4 for matrix B. Nope. Define matrix. Matrix B.
So I got a bunch of fractions for this one. And there's like 4. Wait, no, there isn't. There's only 3.
So 21. Did you do 21 minus 16 and 24 for the other one? For actually
Another one.
for actually solving it.
Oh, I just did A inverse.
Okay, so let me check. So
And that's why I got a bunch of fractions. Yeah.
1 over 27 and stuff. Okay.
Yeah.
So
Weird.
I'm gonna do option matrix A to the minus 1 times by matrix B, which I just put in, 21 minus 16, 24.
Well, I got minus 1, 4, 2 for X, Y, Z.
Mm-hmm. Nice one. 4, 2.
Thank God. This makes life like a billion times easier.
Yep. There's X, there's Y, there's Z. And so that is a very quick way to solve simultaneous equations. And what's good is it scales up. So you could do like 4 by 4 and so on.
Mm-hmm.
Let's leave that for a second. Oh, what the insanity. Why does stuff get insane? Right, let's do this one.
We don't even need to do planes. I don't even know. Okay. Show that they intersect. Simultaneous equations. There we go. So 1 minus 3 minus 4. 6. 5 minus 7. Wait, so this matrix is A, right?
I'm just calling it A.
Okay. 1, 4, 6. Okay. Then X, Y, Z.
And then, that times by X, Y, Z
is equal to 330 minus 3.
330 minus 3. Alright, I better get rid of that A thing then.
And then inverse times.
Yeah.
Should I just give the answer?
Yeah. So that's A. Calling that B. Maybe PQ or something. A to the minus 1 times by B.
One, 2 minus 2. That's what I got.
So 1, 2 minus 2. That's X, that's Y, that's Z. 1, 2 minus 2, boom. Before we do that stuff, we skipped stuff because we were like, that's long, man. So now, those all get easier.
But if it has unknowns, you can't do it on the calculator, right?
No.
Like this one.
But what can you do? What you can do is, they want you to find the inverse. No, you're right. You're right. I suppose what you could do is you could find like the determinant or something, and you would know that like the one with K will be, anything with K in it will be wrong. Like you'd replace K with 1, but the stuff like that wouldn't have K in it,
yeah,
you could do, I don't know if that's a bit quicker. What did we skip?
All have like unknowns. So what is this?
All right, you asked for it.
Oh, I don't like mole rats. They look so ugly.
Huh?
If you look it up, 100 more. Okay. I have no idea how to do this, but it says assign a letter to each unknown. So I should probably start with that. There's youngsters as well.
Oh, you.
So originally there were 100 more.
Din şaplardan edilmişler.
So m plus 100 is equal to f. Originally, I don't know what that means, but
That's back when there was 1,000.
okay. After 1 year, the number of adult males. So after 1 year, it was like 1.02 m.
1.02 m.
And then 1.03 f. I guess. Not really sure. And then 0.96 y. And then when you add them all together, it's equal to 980. Yeah. And then you just solve that, but it's not a simultaneous equation.
I think so. Originally, there were 0 youngsters, basically.
I don't think that's what it means.
I think so.
It doesn't say. It just doesn't say.
Yeah, you're right. After 1 year.
There's 0.
Okay.
Oh, it does say one. There's only meant to be one equation, but it says a matrix equation. What does that mean?
Like what we've been doing. I think we need one more, or maybe we don't. Maybe we do.
This is. Oh, we have to substitute m plus 100.
Yeah, but
Instead of f, and then you solve.
But we've still got 2 unknowns. So there's 1,000 mole rats. Adult males, adult females. I think that it implies that there are 0 youngsters to begin with. And so I think in the beginning amount of males.
I don't think that's possible because the number of youngsters decreased after 1 year. So if there's none in the first place, how did they decrease?
Yeah, you're right. So let's call y the number of youngsters initially.
Yeah, it is the number of youngsters initially.
So is that a third one then? Males plus females plus youngsters is 1,000.
Yeah.
Yep.
So but in the first one and the second one, you can substitute m plus 100 is equal to f. So then you get rid of f.
Yep. So 1.02 m plus 1.03 m plus 100 plus 0.96 y equals 980.
Mm-hmm. And then we have to solve them with like matrix.
Yep.
So 1.02. Wait, maybe you should like expand the m plus 100 first.
It's not. You had to be clever about it. So you have m and y. So you see this f here.
Yeah.
You could also say that is m plus 100.
Yeah.
And then these here.
Plus y is equal.
And so what would y be equal to?
900 minus 2m.
And so that y would be 900 minus 2m. And that way you just have... could
You
just,
have everything in M.
yeah.
Can you still do that with matrices?
So if I was doing it with matrices, I would just do that from the very start and not do any of your clever stuff. So you actually were just solving it. So thing one is, so original males, original females, original youngsters is 1000.
Yeah.
Then after 1 year, 1.02 m plus 1.03 f plus 0.96 y equals 980. And then the way I'd rewrite the first one, the adults, so I'll just write it up here. We said males plus 100 gives you females. You could say males minus females plus 0 youngsters equals minus 100.
But it's not 0. Oh, yeah. But it's not 0 youngsters, so.
How many youngsters up here?
Oh, 0. Yeah, that's true.
Matrix.
And you could just do like normal simultaneous equations.
1, 1, 1.
I feel like you don't really need the matrices method in this question.
You don't need anything, but welcome to maths. 0. That to the minus 1 times by what?
Times by 980 and 100? No, 1000. 980. 100.
Minus 100.
Yay, calculator.
Huh.
Why do they have to do a question about mole rats, though?
Maybe they get studied in the lab or something. Do they lab rats?
I don't think so. They're literally so ugly.
Hmm.
Uh, 100, 200, 700.
100 XYZ or whatever. 100, 200, 700. Sorry. M F Y. 700. 100, 200, 700. There you go. So you can do it purely by matrix. I suppose I should just point out, seeing as how you're getting clever with me. Equation. Simultaneous is 1. 3.
Yeah, I knew that was there already.
Yeah. So you and your cheekiness.
I've never it, but I know it's there.
Yeah. And so you've got that one.
Oh my god, I don't know what this is. We don't have to do planes anymore, and I'm happy.
This is just a visualization. If you had simultaneous equations, let's say 3x minus 2y is equal to 11. And 21x minus 14y equals 77.
They're the same. You would just get
yes. And so because they're like parallel, there's no solutions, and so it would be represented as 2 parallel lines. Here, because it's XYZ, it's 3 parallel planes.
Prism is no solutions, and parallel is no solutions. How does that work?
There's a solution for these two. There's a solution for these two. There's a solution for these two, but there's none for all 3.
Okay, that makes sense. But they're not parallel if they're making a prism.
So just visually, you can see how there's a solution for 2 but not 3. Here there's no solution for any of them, so it's a different thing. Here
different, okay.
And here's this is what we did. It's basically just the same thing 3 times. So they're There's like infinite solutions here.
Yeah.
So when you get one solution, it is this one here.
Mm-hmm.
This one has infinite number of solutions, lots of stuff. So when k is 0. There you go. We could sub it in and try it. You let k be 0, see what you get. You let k be 1, see what you get. You let k be minus 6, and you see what you get. When k is 0, you get minus 18 for the determinant. So there is a unique solution. When k is 1, you get 0 as the determinant. And
There's a lot, infinity of solutions.
And then for c, you get 0 again. And there are no solutions.
How come when you get 0 the first time it's infinite, and then the second it's 0 is like no solution?
I think you have to take it a step further. Yes. So these
They do something.
you break it down to two equations using what we were doing earlier.
Oh, and then you see.
And then you have to do it. Yeah, then you do it that way.
Okay.
This one here, it's times by 3. It's just the same thing. So this one had. Wait.
But that other one was the same thing. This one isn't the same thing.
It's not the same because here.
Yeah. But
Okay.
they don't work, basically.
And then you have exam questions. That one is you put into matrix like we did. Bats. Do you prefer bats?
No, not really, but it can't be worse than mole rats.
Oh, there we go. And so what do you give yourself there?
A tick, I guess. The calculator really made it easier.
Yep. Wow, we discovered that -1 thing. And we can get the determinant.
I don't even know what half the buttons on this calculator do, so.
Nobody does. You know more than most people now. What are we doing next time? We're finished matrices.
Another further maths topic.
Okay. Shall I pick now? No, I should. Is it this? That Gregoire has me doing further mechanics. Let's see. Oh, we could do roots of polynomials or something.
Yeah, don't mind.
Let's give it a go.
Why is transformations in further maths?
Linear transformations, reflections. Brilliant.
Why is that there, though?
Who knows?
Is it like this? I'm guessing it's not the same as GCSE.
No, definitely won't be the same. So let's say roots of polynomials or vectors. I'll take a look at both of them and see. You don't want vectors?
No.
All right. Any questions from you in general?
No.
All right. Sorry for being late today.
No, that's fine.
Well done, Amogha. You did great. I look forward to you typing again next week.
Bye.
Have a good week. Goodbye.